cosecant of x actually is a little easier probably than the secant, just because of which one it goes with. So the cosecant, now we did all the cofunctions. There was cotangent, secant, and cosecant, right? Do you remember which one the cosecant went with? Went with the sine function, right? So really this was kind of going with the sine function, but how is it related to the sine function? Remember? It was the reciprocal, the flip, all that fun stuff. So it's actually 1 over the sine function for what that is going to graph. So we're actually going to graph the reciprocal of the sine function, which means we want to flip the sine over is kind of the idea of what we're looking for. Okay. A couple worries that we have here with this reciprocal, or this reciprocal for cosecant, is we can't divide by 0, right? So we have to worry about where this guy is actually going to equal 0. We'll get to more of that in a second. Okay. First thing we want to do is, since cosecant goes with sine, we want to graph the sine function. Okay. So if I were to graph the sine function, let's go ahead and just do a couple cycles of that. The sine function, if you don't remember, starts at the origin, right? And then we go to the end of the period, which the period for that one would be 2 pi. And that point is on the axis, so that'd be this. Don't do a solid line if you are ahead of me, okay? Okay, the middle one right here, this should be pi, right? And then that for the sine function is right on the axis. And then we would split that in half, and we would go pi over 2. And split that in half and go 3 pi over 2. And that's going to be up at the amplitude and then down at the amplitude. So we're going to go up the amplitude, which is 1, and then we're going to go down the amplitude, which is -1, which would be right there. Okay? So that'd be our sine graph. We don't want to do a solid line yet. Now this sine function is basically our guide for how we're going to graph these. Okay? We're doing 1 over the sine. So we want to take this function right here, which is the sine function, and just do a dotted line. Okay? That's my sine graph. Okay? If I were to put it in there, that's the sine function. Now if I did a couple more cycles of this, let's just go ahead and keep going. Throw a couple more on there, okay? Or at least 1 on there. All right, now this is how it works. We can't divide by 0, right? It's 1 over sine. Sine of x, wherever sine of x equals 0, that's bad for us, okay? Now, anytime we divide by 0, I think we talked about asymptotes for a little bit, right? That was in, I think it was chapter 4, maybe. We had, slant asymptotes and vertical asymptotes. And anywhere where we divided by 0, we had a vertical asymptote, right? So what I want to do is I want to look at the sine function, which I've graphed right here. And anywhere where it crosses the x-axis, this is your x-axis, anywhere where it touches on the line right here, I need a vertical asymptote. Okay, so that means at this point right here, it touches the axis. I need a vertical asymptote right here. Okay, touches at this point, I need a vertical asymptote here. Touches at this point, vertical asymptote, and keep going. Okay, and there's also one on this original line, but it's kind of hard to see a dotted line on the original line, but it is there. Okay. So all these dotted lines are just our guides. We're going to have a ton of dotted lines for all these ones. We want to dotted line the sine function. Anywhere where this guy crosses right here, we want to do a vertical asymptote. Okay. Now once we've done that, we're ready to graph the actual secant and cosecant. Okay. So for this one, for my sine function, it's the flip over. Okay. So if I were to just take this little area right here, this little what looks kind of like a parabola, right? And if I took that piece right there and I flipped it over, that would be the cosecant function. Okay. So if I take this point right here and flip it over, that means my graph is going to go like this and go like this. What the heck is this? Okay, I basically flipped this guy over right there. Okay, they are asymptotes it's going towards, so it's actually going to continue up forever and be good. Okay, now we do that at every single spot, every single maximum or minimum, kind of like those worksheets we're talking about. I just flip that over and draw my parabolas on the ends of it. Okay, so if I have this point right here, that's on a little low valley, I want to flip this guy over, and so that graph's going to go like this and like this. Do the same thing up here, here, and here, and then down here. There. Just cool. That's great for your brain to be thinking about. Your brain is growing. That's good. Good. If it hurts, then it's growing. Like when your muscles hurt, it's because your brain is very strong. Exactly. Or a headache. Okay, so all I have to do for this one, okay, I've drawn my dotted line. This is like my guide, right? And then I'm going to flip that over, okay? So I just flip each one of them over. Now, what's really going on here is this point right here on the sine function, this is the maximum value for that. Is everybody okay with that? That's the biggest number that I can possibly have. If I go 1 over a really, really, really big number, that's going to be a really small number, right? So it's actually going to be the smallest number on this little graph. So it's basically a minimum on this part right here. Okay. Likewise here, this point right here is the smallest number, it's the lowest number. If I go 1 over that, that's going to be the highest number. So it's going to get flipped over and be like that. If you don't believe me, I will show it to you. So let's say I were to graph this. Actually, I can throw this here, and throw this here. And just so, because I have, graph utility, make sure I'm right here, and then clear. So the first one I want to graph is the cosecant. We don't have a cosecant button, so I actually have to put 1 over sine of x on my calculator. And then I'll just 0.6. Let's see what it looks like. Okay, so it looks something like that. Which is exactly what I have, except for I don't have all those lines. I don't have all the dotted lines to help me out, okay? I just basically have this, which is fine. They're virtually the same thing, okay? To check that, just to make sure that it's good, you can actually graph the sine function in there, and that should connect all the little dots right there, okay? So if I go to y equals and graph the sine as well, and graph both of them at the same time, that should just connect on the inside. Now that should have been a dotted line for that one, okay, which actually I can do, I think. I think I can go here, and I think I can say... Maybe. So there's my main graph that I have. That's the actual graph that I'm grading. Okay, that's what I'm looking for. And then there's going to be your guide, so you can't really see that that's dotted. No. It went way fast though, so you know it's going to be dotted. It went way fast. Anyways, all right, he's plugging less points in. Okay, cool. Now, so that's what the parent graph for the cosecant looks like. Okay, remember that. Memorize that. Memorize. No, I'm kidding. You don't need to, right? You're always going to be building these little sines or cosines and whatnot, and be good to go. Okay? So let's go ahead and step it up and make it just a little harder. Just hopefully a little bit harder.
So which line are we interested in?
My solid lines were the answer there. So the solid lines, that would be this piece right here, and this, and this, and this. The rest of the dotted lines are just guides. They're not actually points on the graph. So you just leave it just like that. Yep, exactly. Yep, that's perfect. Now, what I'm grading for, once again, I'm going to be grading for these points right here. Make sure that your increments are correct, right? We all are getting okay at that, I think, I hope. Okay, and then I'll be grading to make sure the graphs are in the right spot. That's the big thing that I'm looking for. Okay? All right, let's go a little bit harder. Let's go ahead and go y equals, let's go ahead and do 2 cosecant of x minus pi. So a little tougher here. Now we're doing the cosecant graph. So what I usually like to start with is figuring out just basically what's my main function that's going on here. I still want to do the amplitude period just like before, but the cosecant goes with the sine function. Okay? So I just put in parentheses, this is really going to be a sine function flipped over, and then I want to use my base graph for sine is this guy right here. Okay? So that's the one graph that you do want to know. Okay? That'll be my dotted line, and that'll help me just be as a guide. Okay? Amplitude, actually the amplitude, the period, and all the other stuff, shifts, are all identical to sine and cosine. So there's nothing new there. Okay? So for this one, the amplitude would be 2. It's going to go up 2 and down 2. And the period for this one's going to be a 2 pi over x, or so over b. And there's nothing in front of there. There's a 1, so it's 2 pi over 1. And then my shift for this one, I'm actually going to go to the right pi. Okay? So that's what this graph's going to look like. Amplitude's 2, period's 2 pi, and then my shift is right pi. So those are the big things that I want to do. Okay, so I'm going to graph just like I'm pretending like I'm graphing a sine function. Okay, don't worry about it being cosecant yet. Just do a sine function as if this were cosine or sine. So first thing I would do is I would go to the right. I would draw my new axis, right? And for my new axis right here, for my new axis, sine starts at the origin, which is going to be that new origin. This right here would be to the right pi, so that's going to be a value of pi. I'm going to go to the end of my period. Once again, arbitrary. You can go out as far as you want there. Period is 2 pi. And I have to add that to my starting value there. So my ending value here is going to be a 3 pi. Okay, I'm going to add those together. Okay, that's at the end of my period, which is right here. Okay, I'm going to split that in half. Sine has the point in the center. That's on the axis. So I've got those. Average of pi and 3 pi would be 2 pi. So this would be 2 pi. See, split that in half. Halfway between pi and 2 pi is 3 pi over 2, I think. And then halfway between here is 5 pi. Okay, so I'm going to split both of those in half. This point's up at the maximum, so I would go up 2, looks like. So I go up 2, this point's right here. I would go down 2, and this point's right here. And now I just draw a dotted line instead of a solid line because it's a reciprocal function. Okay, so we're going to do my dotted line. Do a couple cycles. It helps you see where the asymptotes are just a little bit better, I think. Okay, and anywhere where that graph crosses that axis right there, you need an asymptote. Okay, so we need an asymptote here. We need one here. Anywhere where it crosses 0. And we need that because we don't want to divide by 0. That's a bad thing to do. So we do that. And now we flip over all those little parabolas. and we call it good. Okay, so this guy we're going to flip over. It's going to go like this. This guy's going to go like this. Like this, and like this. And this is considered 2 cycles for this, just so you know. Even though you might think that those are the exact same shape, you still would need one of that for 1 period or 1 cycle, since they are going in the wrong direction, or opposite directions of each other. Or you can just think of how far 1 cycle is on like one of these beginner ones, or one of the signed ones right there, and then see that that'd be 2 periods. Okay? So we're looking for probably 4 total little increments there. Okay? So up, down, left, right, it all makes sense? Not too bad. I can move it up and do the same thing. Now, if I were to move it up, let's say this was a new dotted line right here, that's where I put my asymptotes, okay? And we'll do one of those with the other, okay? All right, let's go ahead and graph the other one. That was cosecant. Both of those were cosecant. So let's go ahead and look at secant real quick. All right, so let's do y equals. Can I make the secant kind of harder at the beginning? Okay. Didn't even finish writing it down, and you're writing it.
That's from our previous videos.
Awesome. It's a lot of work.
So
That writing.
When you work out, you don't work out right after you're done working out. That's like 2 problems in certain, and you just have to stop because you can just gotta be able to
Good thing a little break.
True.
It's called sets.
I think this is a circuit. We're just going one after it.
This is not a race. This is
More of a
workout race.
This is not a battle until you work it.
Your analogies fail.
Just like your battle. It's not a battle, it's a war.
Okay, now this one's the secant, okay? Now the secant is reciprocal with cosine, right? So I want to imagine this is a cosine function. I'll just put that in parentheses. This is really the reciprocal of cosine. And so I want to use the cosine graph. If I were to graph that, put these points close. Are you angry at her? No. Sorry, jeez. That's Okay, so for this one, it is a cosine graph, which means we're going to flip it over because there's a negative in the front here, actually. Okay, so the cosine graph that I would use, I would start down at the amplitude, go ahead and go up, and then come on back down. Okay, so there's 5 points I want to find here. Same as before, I'm still kind of cheating and using the cosine. This is just going to be my guide, okay, my guide for my guide. Awesome. So amplitude is the number in front of the trig function, which is this 2 right here. So amplitude is 2. Okay, my period for this one is pi, I believe. Okay, my shifts up 3, and I guess flip would be considered a. That's not really a shift. It's more because the transformation.
-2, is that what it is?
Yeah, because that negative right there. Yep. And some people would rather write that as a +3 right there. I say conspiracy. That's what I say. They're saving ink, right? See that?
Yeah.
Saving ink. They write it this way. Right? Conspiracy.
True conspiracy.
Anyway, so it is actually an up or down shift. Some might argue that they don't like the +3 on the outside there because they see it as being on the inside of the secant, but it's not. So. Anyways, so here's our main information. Let's go ahead and try to graph this basically cosine. So it's all stuff that we've done before. So let's go ahead and do our main graph here. We've got, let's see, first thing I would do is my shift, which I'm going up 3. So we go 1, 2, 3 on that line. We got our new horizontal line right there. So just an up or down shift on this one. I don't have no left or right. It is getting flipped, which means the cosine is going to start down at the amplitude. And the amplitude is 2. So I got to go down 2 from my new axis. So I'm going to go down 2 and put a point right there. Okay, go to the end of the period. It's going to finish at the amplitude. Finish there. So it's going to finish right here. And that period travel right there, that's how far the period is. So this one's just going to be a pi. Okay, I don't have to add it to anything because technically I'm starting at 0. So 0 plus pi is going to give you pi anyways. Okay? Okay, I'm going to split that in half. Half of that's pi over 2. And that one's going to be up at the amplitude, so we're going to be up 2 from our new axis. So I'm going to go up 2. Right there. I'm going to split that in half, pi over 4. Split this in half. This would be 3 pi over 4, I believe. Okay, and those are both going to be on the new axis. So I'm going to be on this point right here, and I'm going to be on this point right there. Okay, so I'm feeling pretty good, looking pretty good on this one. So on this one now, I want to go ahead and draw my dotted line. This is my guide. Okay, so I'm going to do a cosine guide. So it's going to go something like this. Okay, so there's my guide. There, put probably some extra ones in there. Okay. Now, anywhere where it crosses the new axis here, that's where my asymptotes go. Okay. So I want to do it, and basically it's in the center. It's the center of your function right there. Okay. You wouldn't want to put it. Well, it doesn't cross anywhere down here, right? Nowhere. So you wouldn't use that anyways. So this one, I would put an asymptote right here. I put one right here. Here. Yeah. So.
That would make for an X1, X5 as that conspiracy.
Awesome. I think. Okay, and then now we just do the opposite parabolas, right? Just flip those over and we're done. Okay, so we're going to graph here. Same thing here. It's a, amen, brother. It's almost the same thing. It's so close, right? What's different about it? Just the. How is this different than this? How is that different than this? It's kind of, I can't really start to a different place, right? That's the only difference between the two. That's the only difference. And it's basically the difference, same difference as sine and cosine, right? It just gets moved over a little bit. Same thing, okay? Because remember, we're just using these as our guide just to help us graph this. So. All right, cool. We feeling pretty good about this? Not too bad. Questions for the good of the group before we call it good?
She's good.
She's good. Okay. All right. So, start for you guys to work on.
Good.
Well, if you're good at sine and cosine, then it won't be a big deal, right?
Gunky, son.
If you're still struggling there, then yeah, it might be a little bit.
Wouldn't it go to opposite?